So I'm continuing the earlier giant mammoth tutorial. Some of you may have noticed that our registration resource doesn't really have any sort of data validation, meaning you could send anything to it and it would still handle the message successfully, which isn't ideal. Let's see what I mean. So let me make sure that my registration resource is running. And of course, we need to make sure that the database is running as well. I think I'll just run it in the same terminal. Now, let's curl to the registration resource. So as you can see, the registration ID is not a UUID, and the email address is not an email address. And as you can see, the resource accepts the data without much trouble. They could even be blank or missing completely. Oops, looks like that one results in an internal server error, but you get the point. That's not a great result either. And if we look at the message store, just select from message store.messages. The commands were written to the message store, and this will result in errors downstream. So this is something we need to fix. But when do you validate data? Like, where in the pipeline do you validate the data? If we think of all of the repositories in our application as a hierarchy, we have the registration resource, we have the registration component, the user email address component, the registration view data component, so on and so forth. Do you validate data within the registration component itself, checking each command written to the message store? You could definitely add the validation logic to the handler and write an invalidated event when parsing bad commands. But my preference is to validate data at the edges of the system. If the registration component is the heart of your system, with all of the important logic pertaining to the business therein, we want to validate data as it comes into the system, at the very boundaries, as it transfers from the user's control to our own. And in this case, that's at the registration resource. However, I do want to make a note on trust. For this to work, we need to trust the other parts of our system. Trust that the message contracts are being respected. For example, if some person or component with access to the message store inserts a bad command, then it doesn't matter if we have validation within the registration resource. Therefore, we need to have a certain level of trust that the operators and consumers of our components are respecting those boundaries and contracts. Sometimes we don't have that level of trust in our systems or in our organizations. You need to evaluate your own specific use case to determine whether that's true or not. I can't do that for you. I can only show and demonstrate a certain path. In any case, let's go ahead and code this. We want to update our lib registration resource loader file. Okay, that's done. Next, we want to update the application. Remember that we already parsed the body and formatted it into a JSON hash at registration key within the rack environment. Now, we want to validate that the data at registration key is correct and valid. If it's valid, then we pass it on to the next middleware on the stack, in this case the handler. Otherwise, we return a rack response of an HTTP 400 error. We do this by adding a middleware before the command handler, Next, let's add this file and code this thing. Okay, first let's insert our namespacing. Now let's have an initialize and a call method. We're just going to set these. And if we remember, namespace is registration key. Like that. But we're setting it. Next, we want our call method, which accepts an environment variable. If you remember my tutorial on Rack and how it's the best Ruby web framework, we want to do app call somewhere here. But before we do that, we need to check for errors. So we need to check the registration key on the environment variable, which is a namespace. And we want to send back a hash of errors. Now, we have to set a default value for this hash. Otherwise, we'll have to manually set an empty array before appending strings to those arrays when adding new keys. So that's our default value of an empty array. Then we get registration ID and email address from the input. Now, why do we use the dig method? We can't be sure that the input will have the keys registration ID and email address. These keys might be missing. Therefore, we use the dig method, which if they're missing from the input hash, registration and ID and email address will just be set to null or nil in this case. So if registration ID.nil, we want to append an error to errors at registration ID. Something like this. Registration ID may not be blank. Same thing for email address. And if there are any errors, we return them in an error response. So our body is equal to errors, and we'll go ahead and send it as a JSON string. And then our headers, right now all we care about is the content type, which is application JSON. And then we return a rack response and a 400 HTTP response. And we go ahead and do that. Otherwise, we will move on to the next middleware or onto the application itself. And now, so we're checking whether the registration ID or email address is blank, but we also need to check that they're valid as well. And the way we do this is by doing some sort of regular expression matching. So what I like to do here is define a constant. As you can see, this is the format for a UUID. And we don't really care much about the case, which is why this I is here. And we also want email regexp as well. But we have a little helper here because the URI library has an email regular expression for us to use. So what we do next is check to make sure the registration ID isn't null. And then we match the registration ID with the regular expression. And because we have the unless conditional there, that means we don't have a registration ID that's matched to a UUID. So we can add an error here. And we can do the same thing for email. All right, now let's go and test this. We won't be bothering with automated tests because this resource is so small and simple. We can get away with interactive testing or manual testing. So let's send some bad inputs. So here we see that the registration ID is ABC and the email address is foobar. Oh, before we do that, let me go ahead and clear out the table because we don't want to see these messages. Okay. Yep, we have an empty table. And let me go ahead and send bad input. Oh, first of all, I need to restart this service. Okay, now we're restarted. Let me go ahead and clear the table again. Let's check. Empty. Now let's do this once more. As you can see, we've received an HTTP 400 bad request response, which is what we wanted. And if we check the message store, we can see that we have no messages written to the message store. Let's continue. Now we'll send empty or missing inputs. So let's do the empty input. Let's see. Let me just clear this out. Here, registration ID and email address are both blank. As you can see, we've gotten a 400 bad request response. We have an error payload that says registration ID must be valid and email address must be valid. Let's go ahead and check the database once more. Empty, just like we expected. And now we're just sending an empty payload. And again, we get an HTTP 400 bad request response. Our error message looks a little bit different. Here it says that the registration ID may not be blank and the email address may not be blank. And once more, we can see that there are no messages in the message store, which is what we were expecting. And of course, let's send a valid command. As you can see, we have a registration ID with a valid UUID and an email address with a valid email. And here we see a 202 accepted HTTP response. And if we check the message store, we see that the command was written to the message store as expected. Okay, so recapping, we updated our registration resource at the boundaries of our system so that it would validate data by accepting a valid UUID and a valid email address. And if these things weren't present, the resource would return back an HTTP 400 response. Now, of course, this is a more inelegant method of doing so. It's prone to a lot of mistakes, and I recognize that doing it this way isn't really all that scalable. You could certainly use a library like dry validation or even active model validations, which I might do in a future tutorial. But because Rack is so simple and so flexible, you can bring in other libraries to do things like data validation for you. And as you saw, another great thing with event sourcing, service-oriented architecture, and distributed systems in general is that we don't have to spin up all of our resources and components just to work on and test a small part of the overall application, like you would in a monolith. We only changed and tested registration resource. We didn't touch registration component or user email address component, etc., etc., etc. With strong message contracts, we can work on things in isolation and trust that they'll fit into a broader, cohesive system. Okay, that's all I've got for now. If you have any questions for me, be sure to check out my website, josephchoe.com, or just message me on Twitter, GitHub, one of those social network things. Thanks a bunch!